This little video focuses on how to tackle practical report type questions when you come across them in exams and SACs. Now, the first thing you might be thinking is, what do you mean prac reports? This is not the area of study I'm doing. I'm supposed to be focusing on equilibrium, or I'm supposed to be focusing on organic molecules right now. Well, that's true, but within any area of study, you can be given details of a student practical method or a sample of a practical report that's been written by a pretend student. It's not a real student, let's be honest. And then they can ask you to correctly write any part of the prac report, and they can also ask you to find problems with and maybe suggest improvements, fixes for this student's prac report. They can ask you to say what they've done well, what they've done badly. Okay? If it's in a SAC, it's going to be related to the area of study that you're being assessed on. Okay? The reason they can do this is because this is one of the key skills which goes across all areas of study. Yeah. So, you might see a little excerpt like this, where it tells you the background, it tells you the purpose of an experiment, it tells you a bit about the procedure, it might tell you some results, it might have a bit of a conclusion. One of the first things they might ask you is about variables. Now, there's three types of variables. The independent variable, that's the thing you're consciously changing, and you want to find out the effect of it. The dependent variable, the thing that you're measuring that should in some way depend on your independent variable, your IV. And the control variables, these are things that you are deliberately keeping the same to ensure a fair test. So in this little one, the independent variable, the thing we're changing, is our different catalysts. The dependent variable, the thing that we're seeing, does it have an effect on it, is the enthalpy of the reaction. Now, hopefully you guys know that catalysts don't have an impact on the enthalpy of a reaction, but that's okay. It's all right to find that the effect is no effect. Yeah? You might find a relationship, you might find the effect is there is no effect. Yeah? The control variables in this one, it's got to be anything that could affect the enthalpy, which you don't want to change, otherwise it's going to skew your results. So that might be things like amount in mole of your reactants, because of course if you double the amount in mole, you're going to double your enthalpy values. If you're looking at different catalysts, it might be things like the state of those catalysts, because we know that they work in different ways. It might be things like the amount in mole of those catalysts, because if we're trying to find out the effect of the catalyst on the enthalpy, we might not know that there's no effect. So you've got to keep all of those things the same. Okay? Second thing, one that I know you all love, is errors. Okay? Now, first thing is, calm down. Yeah? You are going to be presented with procedures that have deliberate errors in them. Okay? So, the first thing you look for is things that should have been controlled but aren't. So in this same one we were looking at before, the only thing we should have been changing is the type of catalyst. So if we have a look at it, here they've gone and changed, if we look at our little results, because it's actually got some information in there, they've changed the concentration of the hydrogen peroxide and they've changed the volume of the hydrogen peroxide. Now both of those should have been control variables. Okay? If we were to work it out, they've also changed the amount in mole of our catalyst. Again, that should be a controlled variable. They've also got one of them being a solid and the other one being an aqueous solution. Again, that should have been a controlled variable. So all of these things that have not been controlled, but you should have been, they're automatically your errors. And if you're asking for an improvement, you then say, basically keep it the same. But, maybe go a bit more than that, but you need to go, the concentration of both of them should be 2 molar, say. You might also be asked why, in which case you talk about linking, what happens when you do change that amount in mole. So in this case, the fact that doubling the amount in mole will double the enthalpy value. And then you're not actually investigating the effect of the different catalysts, you're investigating the effect of changing the amount in mole. Okay? Try always, in everything, to avoid generic answers. So try to avoid just saying, keep it the same to avoid to maintain a fair test. That is true, but it's not specific enough. It doesn't tell us why that particular variable being changed is a problem. Now, if you've gone for that, and you've looked for errors, and you've found a couple that should be controlled but they aren't, and they've asked for 3 errors, what do you do next? Well, then you start looking for missing steps, or steps that are just plain wrong. So it would have a step-by-step procedure. Okay, this is a very brief procedure. Okay, yeah, so you would have a step-by-step procedure and look through it and go, okay, well, if it's a titration, have they forgot to mention rinsing, for instance? Okay, those kind of things that you have to do, but which aren't explicitly said within the procedure. Other thing they can ask you to comment on are the accuracy and reliability of the experiment. Now, accuracy means how close you're going to get to the true value. Reliability is your, basically, repeatability of the experiment. So can I repeat your experiment and basically get the same results as you? There are a number of things that affect these two. Doing a lot of repeats within your experiment itself will definitely increase the reliability. So if you're presented with an experiment that's only been done once with one set of data produced, you can say that the reliability is low because there is no repetition. The number of sig figs are the measurements. So, sig figs tell us how accurate we are being. So if you have a concentration that is only to 1 sig fig, for instance, and you're using that then in your calculations, well, that's really going to lower your accuracy, because you might be somewhere in the region of the true value, but you're not going to get that accurate and that close to it. And of course, errors. Yeah? If you have got an experiment with heaps of errors in it, then you're not going to be close to the true value. And also it's quite likely that if you've done things like rinsing errors or things like that, people are not going to be able to repeat it and get the same results. Critiquing conclusions is another one. So they might present a conclusion, and you have to say to what extent do you agree with the student's conclusion, or to what extent is the conclusion valid. Okay? A couple of things you need to do. Firstly, think about it based on the calculations that have been done. Number 1, did the students actually do the calculations? And number 2, did they do it in the correct way? So this little one that I've been showing you, their conclusion, says just comments on the change in temperature, and then says this demonstrates the molar enthalpy, yada yada yada. But they haven't actually calculated the molar enthalpy. And if you don't actually calculate the molar enthalpy, then you can't really comment on it. If they have done it and they've presented calculations, check it. And the easiest way to check it is to do it. Yeah? And do it side by side from where they've written it and see where the problems are. Because I can pretty much guarantee if they've gone to the effort of showing you it step by step, there's going to be problems. The other critique you can make is based on the validity of the experiment. Did it actually set out what it's meant to test? So if it's got heaps of errors in it, that can actually mean that it is not valid because it didn't actually find the effect of your independent variable on your dependent. Yeah? So this one here, where we are changing the amount in mole, then it's actually probably looking more at the effect of the amount in mole on molar enthalpy than it is at the effect of the catalyst. And then finally, the limitations. The limitations of the experiment are, well, under what conditions can we rely on this conclusion? So that might be a certain set of environmental conditions, such as temperatures. It might be under certain currents if you're doing an electrolysis type thing. It might be only with certain chemicals. Yeah? So say, for instance, you're asked to find an order in an electrochemical series, and you find the order at standard lab conditions and at 1 molar solutions. Your limitations would be that actually that is only true under those conditions. So you would say, yes, okay, the order they found is correct, but it is limited by having 1 molar concentrations only and being under these temperatures and pressures. And as soon as you go changing that, that order certainly could change. It doesn't mean their conclusion is wrong, it means that it is limited to only those conditions. Final thing you might be asked about is safety. Now, if they're asking you for a safety concern or what you should do to keep yourself safe, you've got to think about one of two things. Either information given in the question about the chemical, so it might say this is a toxic chemical, this is hazardous or caustic, or this is something which irritates the skin. Okay? Or it's going to be a commonly known chemical that you should know things about. Okay, you are expected to have some general chemical knowledge. So you're expected to know, for instance, that hydrogen is explosive, so you've got to keep it away from naked flames. You're expected to know, for instance, that your group 1 metals are very reactive. Okay? Your safety needs to be specific to that chemical in question. So don't just say, they ask you a safety one, just go, yeah, put on all your safety gear. Yeah, wear your gloves, your goggles, your lab coats, put it all on and you'll be good. If it says it's toxic, then you've got to avoid getting it into the body. If that's a gas, that means having some kind of breathing apparatus. If it's a liquid, then it's saying, well, you know what, avoid drinking it. Yeah, that kind of thing, it has to be specific. If it is something that's highly flammable, keeping it away from a naked flame. Those kind of things. A bit of common sense is needed here.